So good afternoon, sir, class. So for this particular subject, for general psychology, for week 4, our discussion is about sensation and perception. Our sense organs receive message through sensory receptor cells, which receive outside forms of energy like light or vibrations or heat. These are the forms of energy that we have received, and then translate them into a neural impulses that can be transmitted to the brain for interpretation. So the process of receiving information from the outside world, translating it and transmitting it to the brain is called sensation. So the process of interpreting that information and forming the images of the world is called perception. So that is the two clear definition of sensation and perception. So when we say perception, it's a process of interpretation of the information and forming of images of the world, while sensation is the information from the outside world, transmitting it and transmitting that information to the brain is called sensation. All right, so we go on with this particular slides. So the outline of this subject is number 1, defining sensation and perception. 2, limits of sensation or absolute threshold. Third is just noticeable difference and Weber's law. And fourth, the 5 senses. Okay, and the 5th one is perception, interpreting sensory messages. And the last one is the Gestalt principles of perception. So after this, let me give you the meaning of sensation again. So sensation says, sensation is the process of receiving information from the outside world, translating it and transmitting it to the brain. These are the what we call those information from the outside world, which are, as I mentioned earlier, is about like lights or vibration and heat. So perception, on the other hand, is the process of interpreting information and forming images of the world. Now, stimulus the meaning of stimulus refers to any aspect of the outside world that directly influences our behavior and or conscious experience. So stimulus refers to any aspect of the outside world that directly influences our behavior or conscious experience. Okay, and now transduction is the translation of energy in the environment into neural impulse. When we say energy, energy is transduced into neural impulses in the sense organs by sensory receptor cells. And for the sensory receptors, let's see what are these. These are specialized cells that selectively detect and transmit sensory information to the brain. Cell signals via distinct neural pathways. These are the cells or these are the cells that send signals via distinct neural pathways. These are the forms. This one is for the vision. This one is for the hearing. This one's for the touch. And then this form is for the smell, and the last one is for the taste. When we say absolute threshold, the minimum amount of energy an organism can detect is 50% of the time. So a vision, a candle flame of 30 miles on a dark, clear night. Now for the hearing, a ticking clock of 20 feet under quiet conditions. For smell, one drop of perfume diffused throughout 3 rooms. And taste, a teaspoon of sugar in 2 gallons of water. And the wing of a fly flying on your neck from a distance of 1 centimeter. So for the just noticeable difference in Weber's law, just noticeable difference, it is the minimum change in the intensity of a stimulus that can be detected 50% of the time. While for the Weber's law, Max Weber, a psychophysicist in the early 1800s, the amount of change in the stimulus that is necessary to produce a just depend on the intensity of which the stimulus is first presented. So the difference threshold that is being taught is how much stimulus change is necessary for detection. Just noticeable difference, or JND, increases with stimulus magnitude. This is just a reflection of the JND. And then we have the 5 senses. These are the 5 senses that are responsible in transmitting the information on our brain. Number 1 is vision. Second is audition. Third is gustation. Fourth is olfaction. And 5 is tactile. What are these? Let's tackle it. Now, for the structure of the eye, which is for the vision, is we have this particular drawing of our eye. So there is the iris, the cornea, the pupil, and the lens. There is sclera, retina, fovea, optic nerve, and imago. These are the image. So there is an object. Once it is being received from the pupil, then it is transmitted to your lens, going to the inner nerves of your eyes underneath. So there is the theories of color vision. Number 1, the theory of trichromatic theory of color vision. So the description of this: 3 different types of cones, each of which contain a slightly different photopigment that makes the cell particularly sensitive to certain wavelength of light. One type of cone is particularly sensitive to long wavelengths or red. Another is very sensitive to medium wavelength or green. And the third is most sensitive to short wavelengths, which is blue. So there are 3 types of cone, which is particularly sensitive to the different wavelengths. The long wavelengths for the red, and then the medium wavelengths for the green, and the short wavelengths for the blue. That's the theory of color vision. So another theory of this is what we call opponent process theory of color vision. What is this? There are 3 types of opponent process cells in our visual system. That's the red, green, yellow, blue, and black, white. The key to opponent process theory is that these cells can detect the presence of only one color at a time. The colors oppose each other so that the opponent process cells cannot detect either red or green light at any one time. So there are 2 theory about the color vision. That's the opponent process theory, and the other one is the trichromatic theory of color vision. So let's go on with the structure of the ear, which is the second, another part of the five senses that transmits the information to our brain. Okay, the structure of the ear. There is pinna, the outer ear, the middle ear. Under the outer ear, there is pinna, and for the another on the inside of the outer ear is the auditory canal, and in the middle ear, the parts are hammer, anvil, syrup, eardrum, and on the inner ear is semicircular canals, the auditory nerve, and the cochlea. So there are three different area in our ear, the outer, middle, and the inner ear. Okay. For this, we have what we call the auditory pathways of the brain. Once the hair cells convert sound into neural, you see that there is a sound on that. That's the one that has a line here is the one that the sounds received through the canal of the ear. And then once the hair cells convert sound into neural impulses, these impulses must be sent to the brain for further processing. Attached to the end of the cochlea is the auditory nerve. Where is the auditory nerve? There is the auditory nerve, which is on the last side of the inner ear. Once you have that, once these impulses was sent to the brain for processing, that attached to the end of the cochlea is the auditory nerve, and the bundled neurons of the auditory nerve gather the information from the hair cells to relay it to the brain. So after it passed through with the canal, it goes through to the auditory nerve, and then it is transmitted through the neurons going to your brain. And then for the theories of pitch perception, there is 4 different theory. Okay, now first theory is place theory. The place theory is different pitches of sound active specific regions of the basilar membrane more than others. Pitch perception occurs when the brain notices which portions of the basilar membrane are being most excited by incoming sound waves. The second theory is what we call the frequency theory. That includes the hair cells of the basilar membrane fire action potentials at a rate equal to the frequency of the incoming sound wave. The brain determines pitch by noticing the rate of which the hair cells are firing. This theory explains only perception of pitches up to 100 Hz and the maximum firing rate of a hair cell. Okay, for the third theory is what we call the valley theory. So similar to frequency theory, this theory states that groups of hair cells fire as teams to give us a perception of pitches over 100 Hz. For example, 3 hair cells can each firing 100 Hz together yield the perception of 3000 Hz tone. So for the last theory is what we call the duplicity theory. This theory states that a combination of a frequency and place information is used in pitch perception. Exactly how these sources of information are integrated in the brain is still being investigated. So for the other senses, we have what we call the gustation, which is the sense for the taste, and the olfaction, or the sense for the smell. So chemical senses require certain chemicals to come into direct contact with our sense organs. The station is certain chemicals in foods and other substances may be dissolved in our saliva and come into direct contact with the sense organ commonly known as our tongue. And for the olfaction or the sense of smell, the chemicals nearby air from food or other substances may come into contact with cells in the nasal cavity. Okay, so that's under the nose or the nasal cavity. So some facts of the gustation. There are about 10,000 taste buds on the tongue, and each taste bud contains approximately a dozen sensory receptors called taste cells. So taste cells are sensitive to chemicals in our food and drink. So papillae are cluster of taste buds on the tongue that responds to thousands of chemicals. And there are taste buds that respond primarily to chemicals that give rise to the sensation of sweetness like sugars, and the sourness most likely for acids, and saltiness most likely for salts, and bitterness in response to a variety of chemicals that have no food value or are toxic. Another facts about gustation, there is evidence that there is a fifth type of taste bud which give rise to the sensation of fattiness in response to fats. Some scientists believe that there is another kind of taste bud that give rise to the sensation called umami, the savory taste of meat stock or cheese and mushroom. But this has been shown to arise from the same taste bud that give rise to the sensation of sweetness. So we lose taste buds as we age, especially over 45 years of age. Babies have the most taste buds and are very sensitive, whereas older adults are less sensitive to the chemicals that give rise to taste sensation. Those are the some facts of the gustation. So for the other senses, chemicals, some facts of the olfaction or the sense of smell. Olfaction, olfaction, our sense of smell has adaptive value. Smells can alert us to danger. The ability to smell smoke enables us to detect a fire long before we see flames. Chemicals in the air we breathe pass by the olfactory receptors on their way to the lungs. These receptor cells are called olfactory epithelium, located at the top of the nasal cavity. So what are the other facts of olfaction? Sorry. Nearly all the chemicals that humans can detect as odors are organic compounds, meaning they come from living things. In contrast, we can smell very few inorganic compounds such as rocks and sand. So when it comes to discriminating between odors, we can detect roughly 500,000 different scents, and we can identify by name about 10,000 different smells as to capture our attention. And for the other senses like the skin, other senses or the skin which is cutaneous. For the tactile, some facts about the skin. The skin can detect only 3 kinds of sensory information such as pressure, temperature, and pain. And there are 4 types of receptors in the skin. Number 1 is free nerve endings. Number 2 is the basket cells. The third is the tactile disc. And the last one is the specialized end bulbs. So on this, there are free nerve endings. So for the free nerve endings, sensory receptor cells in the skin that detect pressure, temperature, and pain. So we have the nociceptors. In the free nerve endings serve as a receptors for stimuli that are experienced as painful. Ano ba yung mga, what are the painful signals? These painful signals are regulated in 3 parts of the nervous system. Number 1 is the brainstem. Second is the spinal cord. And the third is the peripheral pain receptors. We have the basket cells. What is this? These detect pressures. We have the tactile disc detect pressure also, and specialized end bulbs also detect pressure. So we have also the body senses. For the body senses, we have the vestibular organ. The vestibular organ is a complicated set of sensory structures located in the inner section of the ear, where it provides the cerebral cortex with information about orientation and movement. And there are 2 sets of small sensory structures in vestibular organ. Number 1 is what we call the saccule or an utricle. So a fluid-filled sacs in the inner ear that contains sensory receptors that keep the brain informed about the body's orientation. For the semicircular canal, that provides the most sensitive message to the brain about orientation. And for the, again, for the body senses, we have what we call the kinesthetic receptors. What is this? Individual sensory receptors that provide detailed information on the orientation of the head and body, differences in pressure due to gravity, and movement on different parts of the body, the movement of each part, and host of other kinds of information. This is located in the muscles, joints, and skin, provide additional messages about movement, posture, and orientation. And for the perception, the interpreting sensory messages. So it says that perception is the interpretation of sensation. It's an active process in which perceptions are created, often go beyond the minimal information provided by the senses. So we have also a gestalt principles of perception. There is the proximity, the similarity, the closure, and continuity and symmetry. So these are the gestalt principle of perception. We have 1, 2, 3, 4, and 5. That's proximity, similarity, and closure, continuity, and symmetry. So for the gestalt principle of perception, first, we have the figure ground. We perceive a visual stimulus. Part of what we see is the center of our attention. The figure and the rest is the indistinct ground. Second, when we say continuity, we tend to perceive lines or patterns that follow a smooth contour as part of a single unit. And third, for the proximity, things that are proximal or close together are usually perceived as belonging together. And for the similarity, similar things are perceived as being related. And for closure, missing sensory information is automatically filled in the process of perception to create complete and full perceptions. There are 2 types of perceptual constancy. So number 1, perceptual constancy, the tendency for perception of objects to remain relatively unchanged in spite of changes in raw sensation that include brightness constancy, color constancy, and size constancy. And we have also the shape constancy. So we also have the visual perception constancy. So under this, we have here a figure showing this one. So for the depth perception, a monocular cues to depth perception can be perceived by one eye. We use these monocular cues in everyday life, and artists manipulated them to create images in art that appear to have depth on flat surfaces and to bring computer animated figures to life. So number one, we have the texture gradient. The texture of an object is larger and more visible up close and smaller when far away. One curved surfaces, the elements of textures are also more slanted when the surface is not squarely face us. And the second is the linear perspective, which is object can cast smaller images on the retina when they are more distant. As a result, parallel lines such as railroad tracks appear to grow closer together as the farther away as they are from us. So this is a figure for monocular cues. This one is also monocular cues, texture and texture gradients. This is the monocular figure for shading. And for depth perception, we have the superposition, which color objects tend to be partially in front of or partially cover up more distant object. For the shadowing, the shadow cast by objects and highlights of reflected light suggest their depth. And fifth one, speed of movements. Objects farther away appear to move across the field of vision more slowly than do closer objects. And for the aerial perspective, water vapor and population in the air scatter light waves, giving distant objects a bluish, hazy appearance compared with nearby objects. 7 is the accommodation. The shape of the lens of the eyes must change to focus the visual image on the retina from stimuli that are different distances from the eye. And the 8th one is the vertical position. When objects are on the ground, the farther they appear to be below on the horizon, the closer they appear to us. For objects in the air, however, the farther they appear to be above the horizon, the closer they appear to us. Okay. And for the depth perception, this is the last topic. We have the binocular cues in depth perception require both eyes to allow us to perceive depth. The two binocular cues are number one, convergence. When both eyes are looking at an object in the center of the visual field, they must angle inward more sharply for a near object than for a distant object. And the second one, cue, is the retina disparity. Because our two eyes are a couple of inches apart, they do not see the same view of three-dimensional objects. Especially when the object is close, this disparity or difference between the images of the two retinas is a key factor in depth perception. So humans have specialized motion detectors. This is the figure. We have an apparent movement. If you see this figure, okay, you can see that in your eyes. So these are for any references. You can also look into your books for psychology of introduction written by McGraw-Hill and the others. So that's the last topic for the slides. We will continue.